Hello and welcome back to 180 Get 5 May for AP Precalculus. This is episode 21, and today we're going to be doing a problem from Unit 3 involving a polar function and graphing it. So let's just get into it. Before I do the problem, I'd like you to pause the video and try it yourself, and then just check back and see how you did. Alright, so assume that you pause the video. We have the polar function r equals 6 cosine theta. So what this means is that our r value that we're going to graph, which is how far away we are from the origin, is going to be 6 times the cosine of whatever our angle is. So, write this out. 6 cosine theta. I like to remind you that cosine has a period of 2 pi, which means that's going to repeat every 2 pi, which is one full loop around the circle, right? But that means that we only really need to plug in values from 0 to 2 pi. So let me just create a table real quick. Wait, do I have that on? Second. Oh yeah, I don't want that. Yeah, okay. Apologize. Alright, let me create my table. 0, pi over 6, pi over 3, and then pi over 2, and then 2 pi over 3, and then 3 pi over 4, and then 5 pi over 6, and then pi, and then, oops, I think it is, let me think. Next we'll have 7 pi over 6. And then we'll have over here, which is pi over 3. Let me just think. Pi plus pi over 3. That's, yeah, 4 pi over 3. And then 3 pi over 2. And then this here is, that's going to be 11 pi over 6. And then 2 pi. This is going to be 5 pi over 3. Alright. Okay. So those are our theta values, and this is our r. This is a big table. Okay. Now it's not too bad. We just need to think of our cosine values. And then multiply whatever we get by 6. Because we're taking 6 times the cosine of our angle, right? Okay. Alright, so cosine of 0 is just 1. Cosine of pi over 6 is going to be square root 3 over 2. And then the cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0. Cosine of 2 pi over 3 over here is negative 1/2. Cosine of 3 pi over 4 is, wait, did I miss? I think, yeah, this is an extra value. We're only going by pi over 6. Oops. This value over here, that's going to give us negative square root 3 over 2. And then pi will just give us negative 1. And then 7 pi over 6 will give us negative square root 3 over 2. 4 pi over 3 will give us negative 1/2 again. And then here, it will give us 0. At 5 pi over 3, it will be 1/2. At 11 pi over 6, it will be square root 3 over 2. And at 2 pi, it will be 1 again. Okay. Yeah, this is an extra value I didn't mean to add. Okay. Now, actually, that's for cosine, just the cosine of the angle. We want to do 6 times this, right? So 6 times square root 3 over 2, it's going to be 3 root 3. 3 times 1/2 is just 3. I'm going to do the same with all of these. Alright. It's going to be negative 6. It's going to be negative 3 root 3. Negative 3. Again, if you see me doing like just work like this, or I'm just filling in a table, feel free to like, speed up the video. Or skip forward or whatever. Okay. Alright, now we can start to graph our function. So we know at 0, we're going to be over at 6. We're going to have a radius of 6. So 1, 2, 3, 4, 5, 6. Okay. And then pi over 6, we're going to be at 3 root 3, which I should probably type an approximation for those in my calculator. This is going to be about 4.33. It's going to be negative 4.33 about. Oops. Okay. Alright, so at pi over 6, we're about 4.33. So 1, 2, 3, 4. About there. For pi over 3, we're at 3. So we are here. And then we are at 0. And at 2 pi over 3, we're at negative 3. So this is our angle. Our angle is in that direction. But our radius is negative, so we want to go the opposite direction. So 1, 2, 3, this way. And then for 5 pi over 6, we have negative 3 square root 3. So we're going to go this way. 1, 2, 3, 4. It's about 4.33. So about there. It's going to be our point. And that pi, it's negative 6. So 1, 2, 3, 4, 5. Well, no. Our angle is this way. But we're going to go the opposite direction, 6. So our point's going to be there. And then, okay. And then 7 pi over 6, negative 3 square root 3. So we're going to go to this point. There's a lot of repeats. And then at 4 pi over 3, we have negative 3, which is going to bring us over here again. At 3 pi over 2, we're at 0. At 5 pi over 3, we are at 3. Which matches up with that. At 11 pi over 6, we are at 3 square root 3, which matches up with that. And at 2 pi, we are at 6. So actually, if I would have done it earlier, if I would have just made a table, I would have seen, or no, it's generally good if your function has a period of 2 pi to go out to have table values that are between 0 and 2 pi, just to make sure that you don't have any, like, you don't miss anything. So, yeah, as you can see, though, this is going to be our shape. So, it's going to look something like... Probably not a great sketch, but... let me pull up Desmos real quick. If we graph it ourselves, if we do r equals 6 cosine theta, get something like this. So it's a bit more circular than what we had. So if I were to adjust it, might be a little more like... Yeah, it's still not great. But, yeah. Anyways, let me try and get one good sketch. Yeah, I hope that you enjoyed the video. I hope that you found it helpful for graphing polar functions, and I hope that you have a good rest of your day.